Welcome to a channel which makes a topic which totally isn't your cup of physics into a topic which hopefully at least kind of is your cup of physics. Today we're starting with the very basics. We're going to be first looking at how to fill in the beginning of your exam. Don't forget to always read the instructions. Yes, you may think that this part is worth skipping, but please don't skip it, because all of these little pieces of information that you're about to get are very useful and very important for you to get full marks as well. First things first, write your center number, candidate number, and name on all the work you hand in. Obviously this doesn't apply to your revision, but once you're in the exam, it's just good practice that you always do these things so that you don't forget in the exam room. They're gonna make you do this and check that you have done this, but then other centers maybe might not be as careful, so the responsibility ultimately is on you to do this. Next point, write in dark blue or black pen. Don't forget this either. I'm going to be annotating for you, and this is going to be done in color, but this can only be done during your revision. Don't do this during the exam, okay? You are not supposed to use any staples, paper clips, glue, or correction fluid, so any mistakes that you make, just cross them out instead of using the correction fluid on them. Of course, don't forget to answer all the questions, and remember that physics is a subject where you can use your calculators. Just make sure that you really do know how to use it in the exam. Remember that anytime you do not show your working or you do not use appropriate units, this may lose you marks. So whenever you see 2, 3, or more marks, sometimes even when you see 1 mark, they still want you to show your working. Although sometimes you might get full marks for not showing your work, you should know that that is an extremely bad practice for your physics learning. So you should just not do it and just show your work all the time. Okay, so the next point is take the weight of 1 kilogram to be 10 newtons. When you get to A level, you will take this to be 9.81 meters per second squared, which is the true acceleration of free fall, but for now just stick to 10. At the end of the exam, fasten your work securely together. This will probably not be needed, but just in case, you should be aware. And the number of marks given are in brackets at the end of each question or part question. And you should definitely pay attention to these, as they will give you hints as to how much you should be writing down. Okay, now let's get straight into the paper. The instructor gives a student a sudden order to stop the car in the shortest possible time. Figure 1.1 shows the speed time graph of the motion of the car from the moment the order is given. The order to stop is given at time t is 0 seconds. First part, state the speed of the car at t equals to 0 seconds. This is something that you should be able to read from the graph. That is why there is only 1 point assigned to this. So if we have a look at the time axis where it is 0, the speed there is, let's see, 10, 15, 18, so it is 18 meters per second. Don't forget to include the unit. If you do not include the unit, you will lose your mark here. Part 2 of this first question A is a part that I'm going to leave out for now, because actually going over this question for the first time, I didn't read the question at all and I messed up this part completely. So I'm just gonna come back to it when I finish the rest of these. Okay, so moving on. The next part of the question says calculate the deceleration of the car between the time 0.9 seconds and 4.0 seconds. So again, we go to the graph for this and we find out that the initial speed at time 0.9 seconds is 18 meters per second, and the final speed at time 4 seconds is 0 meters per second. We can put all of this information down next to the question so that we have it directly in front of us. Now, if we think about what deceleration is just negative acceleration. And if we think about what acceleration is, it is the change in velocity over change in time. In this case, we're saying that speed and velocity are the same thing. So when we say that acceleration is change in velocity over change in time, what we mean is that it is the change in speed over change in time. So we can write that with an equation. A equals to final speed minus initial speed over final time minus initial time. If we plug in all of the numbers, we get minus 18 over 3.1, which means that our acceleration is minus 5.80645 meters per second squared. Now, there are two things that you need to remember here. First is that we already said that deceleration is negative acceleration. So if we just calculated a negative acceleration, it means that our deceleration is actually going to be 5.81 meters per second squared. The other thing that you need to remember is the significant figures you want to be using. Remember that at IGCSE level, the optimal number of significant figures is going to be either 2 or 3. Usually if you go for 2, it's enough. So there's no need to include all of these numbers that you have just calculated. You can just say deceleration is 5.8 meters per second squared. And again, don't forget about the unit, because without the unit, you won't score this mark. On screen here, I'm just reiterating what I just said. And I'm also explaining why the 2 marks could be awarded. And this is true for all calculations, so be aware of this. Now, if we move on to the next question, it's asking about the total distance traveled by the car from time t equals 0 seconds. Remember that the distance traveled is going to be the area under a speed time graph. I forgot an A here, but that's supposed to be area. And they expect you to state this, which is why I just copied it again. Now, if we look at the graph, we have 2 areas here. Well, in fact, we could say that we have 3 sections and each section has its own area. So the total distance traveled is going to be area 1 plus area 2 plus area 3. We've already seen that area 3 is not really an area, it's just a line. So the third area is going to be 0. Now, if we look at the first 2 areas, area 1 is going to be 0.9 times 18, and area 2 is going to be 3.1 times 18 times a half, because it is a triangle. You can also pause the video where I show the graph and you will see how I got the 3.1. I just looked at the difference between 4.0 and 0.9. Now, as I said before, since the line of area 3 is at 0, this means that area 3 is just equal to 0. This means that when we punch in all of the numbers into our calculators, we get out that D equals to 44.1 meters. Again, don't forget about the unit. Because they're asking about a distance, this unit is going to be meters. Above here, I've just worked out the units for reference, just in case if you need some further clarification. Okay, let's move on to the next question. Describe and explain a danger to a driver of not wearing a safety belt during a sudden stop. Now note that you have 1 mark for description and 1 mark for the explanation. And if we think about it, let's describe the situation first. Without a seatbelt, when the car stops, the driver's body would keep moving due to Newton's third law. I forgot an apostrophe there for drivers. It would have been driver apostrophe S. And for the explanation, this means that he would fly out the window through the windshield. Now, if I go back to the question that I have messed up before, because I didn't read the question, and if I carefully read it now, I can find out that the answer to the question is actually really easy, and it just basically shows you that 0.9 seconds is the student's reaction time. I can check the mark scheme to see that everything is correct, and it is. That's it for today. Thank you for watching, and I hope that if this topic wasn't your cup of physics before, it at least kind of is your cup of physics now.